Aerial refueling, also known as in-flight refueling or air-to-air refueling, represents one of the most critical capabilities in modern aviation operations. This sophisticated process involves transferring aviation fuel from one aircraft, called the tanker, to another aircraft, called the receiver, while both aircraft remain airborne and in flight. Here we can see a real-world example of aerial refueling operations, with a KC-135 Stratotanker refueling F-16 Fighting Falcons during a military mission. Aerial refueling provides three critical advantages for military and aviation operations. First, it dramatically extends the operational range of aircraft, allowing them to reach distant targets without intermediate stops. Second, it increases loiter time, enabling aircraft to remain in a specific area for extended surveillance, combat air patrol, or support missions. Third, it enhances payload capacity by allowing aircraft to take off with maximum weapons or cargo loads instead of carrying extra fuel, since they can refuel in flight. Military operations require precise coordination and formation flying. This diagram illustrates the designated refueling areas and formations used around tanker aircraft during aerial refueling operations. Aerial refueling is absolutely crucial for modern military operations, enabling long-range missions, global force projection, and operations in areas where landing facilities are unavailable or compromised. This capability transforms the strategic reach and operational flexibility of air forces worldwide. Aerial refueling operations utilize two distinct primary methods, each with unique characteristics and applications. These systems represent different engineering approaches to the challenge of transferring fuel between aircraft in flight. The first method is the probe-and-drogue system, which employs a flexible hose with a funnel-shaped basket called a drogue. This system is characterized by its operational flexibility and widespread adoption. The second method is the flying boom system, which utilizes a rigid, telescoping tube equipped with movable flight control surfaces. This system enables higher fuel transfer rates through its robust mechanical connection. The probe-and-drogue system features a flexible hose design with a funnel-shaped drogue that the receiver aircraft connects to using an extended probe. This configuration provides high operational flexibility and is particularly well-suited for naval operations. The flying boom system employs a rigid, telescoping tube equipped with flight control surfaces, allowing a boom operator to precisely guide the connection. This system achieves higher fuel transfer rates due to its robust mechanical coupling. The adoption patterns of these systems reveal distinct operational preferences across different air forces worldwide. Statistical analysis reveals that approximately 80% of the world's air forces utilize the probe-and-drogue system. This widespread adoption is attributed to the system's operational flexibility and compatibility with various aircraft types, particularly naval aviation platforms. The flying boom system, while representing approximately 20% of global usage, is predominantly employed by the United States Air Force. This system's higher fuel transfer rates make it particularly valuable for large-scale strategic operations and heavy aircraft refueling missions. This operational photograph demonstrates the flying boom system in action, showing the rigid boom extending from the tanker aircraft toward the receiver. The precision required for this connection exemplifies the technical sophistication of modern aerial refueling operations. This comprehensive comparison illustrates the fundamental differences between the two primary aerial refueling methods. Each system offers distinct advantages tailored to specific operational requirements and aircraft configurations, ensuring that modern air forces can select the most appropriate refueling solution for their strategic needs. The aerial refueling process is a precisely choreographed sequence that begins long before the aircraft make physical contact. This complex procedure requires exact coordination between tanker and receiver aircraft. The refueling process begins with both aircraft rendezvousing at a predetermined location, typically designated as an Air Refueling Initial Point or ARIP. This location is carefully selected based on airspace restrictions, weather conditions, and mission requirements. As shown in this diagram, the receiver aircraft initially maintains a position 1,000 feet above the tanker aircraft. Both aircraft follow specific approach vectors to ensure safe separation during the rendezvous phase. Once the rendezvous is complete, the receiver aircraft must transition into close formation flying. This requires the receiver to move to a precise position behind and slightly below the tanker aircraft. The receiver aircraft approaches from behind and below, gradually moving into the pre-contact position. This positioning allows for optimal fuel transfer while maintaining safe separation between the aircraft. During formation flying, the receiver pilot relies on director lights mounted on the tanker aircraft and radio communications from the boom operator. These guidance systems provide precise positioning information to maintain the correct formation. The director lights provide visual cues. A green center light indicates proper position, while red directional lights guide the pilot to make necessary adjustments. Simultaneous radio communication ensures precise coordination throughout the process. Once contact is established, the receiver pilot must maintain position within what is known as the air refueling envelope. This is a three-dimensional space that defines the safe operating parameters during fuel transfer. The air refueling envelope defines the acceptable limits for lateral, vertical, and longitudinal movement. Staying within these parameters ensures safe fuel transfer while preventing dangerous contact between the aircraft structures. This precise coordination between rendezvous procedures, formation flying, guidance systems, and envelope management demonstrates the remarkable skill and technology required for successful aerial refueling operations. Aerial refueling is fundamentally a fluid dynamics operation, where precise control of fuel flow enables aircraft to transfer thousands of pounds of fuel per minute while flying at high altitudes. This image shows a KC-135 Stratotanker refueling an F-4 Phantom fighter jet using the flying boom method. The rigid boom extends from the tanker to establish a direct fuel connection with the receiver aircraft. The fuel transfer system consists of the tanker aircraft with its fuel tanks, a transfer mechanism such as a boom or hose, and the receiver aircraft with its fuel receptacle. Fuel flows from the tanker's pressurized fuel system through the boom or hose connection. The flow is driven by pressure differentials and gravity, creating a continuous stream of aviation fuel. Modern aerial refueling systems can transfer fuel at rates up to 1,200 pounds per minute. This is equivalent to approximately 180 gallons per minute, allowing rapid fuel transfer during the brief connection window. This image shows a probe-and-drogue refueling system, where the flexible hose and drogue basket allow for fuel transfer. Several factors affect the actual transfer rate, including pressure differential between aircraft, the diameter of the fuel line, fuel viscosity, altitude conditions, and the specific system design. The fundamental physics of fuel transfer follows basic fluid dynamics principles. The flow rate equals the cross-sectional area of the fuel line multiplied by the fluid velocity. This relationship helps engineers optimize refueling systems for maximum efficiency. These high transfer rates enable aircraft to quickly replenish their fuel supply during brief refueling windows, allowing them to extend their range and continue their missions without landing. Modern aerial refueling is undergoing a technological revolution. Advanced automation systems and unmanned aircraft are transforming how fuel transfer operations are conducted in the skies. The evolution from traditional manual control systems to advanced automation represents a significant leap forward. Where human operators once managed every aspect of the refueling process, sophisticated computer systems now provide unprecedented precision and reliability. Automated boom control systems represent the pinnacle of precision engineering. These systems use advanced sensors and computer algorithms to maintain perfect alignment between the tanker's boom and the receiving aircraft's fuel receptacle, eliminating human error and increasing safety. The Airbus A330 multi-role tanker transport achieved a historic milestone as the first aircraft certified for fully automatic boom operations. This breakthrough demonstrated that computer systems could safely and reliably manage the complex process of aerial fuel transfer without direct human intervention. Real-time data analytics form the backbone of modern automated refueling systems. Advanced computer vision algorithms process stereo imagery, while neural networks analyze positioning data to ensure perfect alignment throughout the fuel transfer process. The development of unmanned tanker aircraft, exemplified by the MQ-25 Stingray, represents the future of aerial refueling. These autonomous systems can operate without human pilots aboard, significantly reducing risk while maintaining the precision required for safe fuel transfer operations. These technological advancements deliver unprecedented mission flexibility and dramatically reduce operational risks. Unmanned tankers can operate continuously without crew fatigue limitations, while automated systems eliminate the possibility of human error during critical fuel transfer operations. As these technologies continue to mature, they will fundamentally transform aerial refueling operations, making them safer, more efficient, and more capable of supporting complex military and civilian aviation missions worldwide. Aerial refueling represents one of the most challenging and demanding flight operations in military aviation. The precision, skill, and extensive training required make it a true test of pilot expertise and human coordination. Among all flight maneuvers, aerial refueling ranks at the extreme end of the difficulty spectrum. It requires pilots to maintain precise formation flying while managing complex fuel transfer operations in three-dimensional space. Pilot training for aerial refueling follows a progressive, multi-stage approach. Beginning with comprehensive ground school instruction, pilots learn the theoretical foundations, safety procedures, and communication protocols essential for successful refueling operations. The training progression moves from simulator-based practice to actual formation flying, where pilots develop the precise control skills necessary to maintain position relative to the tanker aircraft during fuel transfer operations. From the pilot's perspective, aerial refueling requires maintaining an extremely precise position relative to the tanker aircraft. This cockpit view demonstrates the challenging visual references pilots must use to stay within the critical refueling envelope. Boom operators require specialized training distinct from pilot training. They must master the complex coordination of boom control systems while maintaining constant spatial awareness of both aircraft positions and fuel transfer parameters. The boom operator must precisely control the flying boom's position and insertion into the receiver aircraft's fuel receptacle. This requires exceptional hand-eye coordination and the ability to make real-time adjustments based on both aircraft movements. Success in aerial refueling operations demands exceptional proficiency across multiple critical skill areas. Pilots and boom operators must maintain precision control within extremely tight tolerances while demonstrating rapid reaction times and comprehensive situational awareness throughout the entire refueling process. The human element remains the critical factor in aerial refueling success. Despite advancing automation technologies, the complex decision-making, adaptability, and precision required for safe fuel transfer operations continue to depend on highly trained and skilled aviation professionals. Aerial refueling has evolved from experimental aviation to a cornerstone of modern military operations, fundamentally changing how air forces project power across the globe. The story begins on June 25, 1923, when two United States Army Air Service pilots achieved the first successful mid-air refueling between two Airco DH-4B biplanes. This pioneering experiment demonstrated that aircraft could extend their operational range beyond the limitations of their fuel tanks. During the Vietnam War in the 1960s and 1970s, aerial refueling proved its strategic value. Military aircraft could now reach distant theaters of operation, extending their combat radius far beyond what was previously possible. This capability became essential for sustained air operations over Southeast Asia. Today, aerial refueling remains a critical capability that enables modern air forces to conduct global operations. Let's examine some real-world examples of this technology in action. This image shows a KC-135 Stratotanker refueling an F-4 Phantom II fighter jet using the flying boom method. The rigid boom system allows for high fuel transfer rates, making it the preferred method for U.S. Air Force operations. Modern aerial refueling operations continue to use similar principles, but with advanced aircraft and improved safety systems. Here we see a contemporary example of a KC-135 Stratotanker refueling an F-16 Fighting Falcon. This demonstrates how aerial refueling technology continues to be essential for modern Air Force operations, enabling extended missions and global reach. Today's aerial refueling operations are conducted over 600,000 times annually worldwide, supporting everything from routine training missions to critical combat operations. Modern aerial refueling supports global military deployments, extended combat operations, and even humanitarian missions. This capability has transformed from an experimental concept in 1923 to an indispensable tool of modern air power, enabling forces to operate anywhere in the world with unprecedented flexibility and reach. From its humble beginnings nearly a century ago to its current role as a force multiplier for modern air operations, aerial refueling continues to evolve and adapt to meet the challenges of contemporary military aviation. The future of aerial refueling is evolving beyond traditional fuel transfer operations. Modern developments focus on multi-role tankers and commercial aerial refueling solutions that enhance operational flexibility and cost-effectiveness. Multi-role tankers represent a significant advancement in military aviation. The Airbus A330 multi-role tanker transport exemplifies this concept, combining traditional aerial refueling capabilities with cargo transport, medical evacuation, and passenger transport functions. Medical evacuation represents a critical multi-role capability. These aircraft can transition between refueling missions and medical transport operations, providing strategic and tactical medical evacuation services while maintaining their primary refueling function. The United States Air Force is exploring commercial aerial refueling as a supplementary solution. This approach involves contracting civilian operators to provide refueling services, reducing the burden on military tanker fleets while maintaining operational effectiveness. These future trends offer significant operational benefits. Multi-role tankers and commercial aerial refueling provide enhanced cost-effectiveness through dual-purpose utilization, improved operational flexibility by combining multiple mission types, and increased capacity to meet growing refueling demands. These innovations represent the evolution of aerial refueling from single-purpose operations to comprehensive multi-mission platforms. The integration of commercial solutions and multi-role capabilities ensures that future aerial refueling operations will be more efficient, cost-effective, and adaptable to diverse operational requirements.